Good morning, children. We continue with the lesson 2, lithosphere. Now, just before going to the what we are going to study, let me tell you that last class we studied what is the Earth's interior, that is crust, mantle and core. Then we studied about the different types of rocks. Now we will study what are the forces of the Earth's crust. Now today we are going to study about the internal forces and the external forces. Now the earth has two important forces that change the face of the earth. First one is internal forces. These are the forces which originate inside the crust and influence the surface feature of the earth, example volcanoes, earthquake, etc. The internal forces are also called endogenic forces. Now, as the name suggests, internal forces, any changes in the interior of the earth, whatever changes it brings, it changes the surface features of the earth. When volcano occurs, the magma comes out, we find different types of rocks. Earthquake occurs, the tremors bring so many changes. So these are also called as the endogenic forces. Now next we will see volcanoes. Now a volcano is a vent or narrow opening in the earth's crust connected by a pipe of an underlying magma. Rock fragments, lava, ash, steam, flames and other gases are emitted from the interior of the earth. A passage in the earth's crust through which magma and other volcanic materials are ejected is called vent, and the funnel-shaped hollow at the top of the cone of a volcano is called crater, and a large basin-shaped crater bounded by steep sides is known as caldera. Now you are familiar with the word volcano. I will show you the diagram. Now you see here the structure of volcano. Now down you see the magma chamber. As we have said, the interior, we have studied that the crust, mantle and core, through core and the mantle, the lava, it will be hot. So the lava comes through a vent type, and there you see the crater cone, the lava comes out and ash and gas and all the whatever inside comes out, and this is called as the volcano, whatever comes out. Remember, volcanoes also give us the pollution which comes because of the ash and gas which comes out. Now next we will see, you can see the different volcanoes. The other two volcanoes are no longer, they are erupted. Once upon a time they were erupting. Now I will tell you the types of volcanoes. Now on the basis of the periodically or frequency of eruption, volcanoes are classified into three types. Now the first one is active volcanoes. Volcanoes which constantly eject lava. Eject means throw out lava, gases, ashes, etc. are known as active volcanoes. And there are about 600 active volcanoes in the world. For example, Mount Stromboli and Mount Etna in Italy, St. Helens in USA, Mauna Loa in Hawaiian Islands, and Pinatubo in Philippines. You can see the pictures here. These volcanoes are still active. Time to time they throw out, they eject the lava, magma, all the interior of the earth comes out. Now dormant volcanoes. Dormant volcanoes are those volcanoes which have erupted in the past and are likely to erupt again but have remained inactive for fairly long period. That means earlier they had erupted, now they may or may not erupt. So at present for fairly long time they are quiet. So here examples are Mount Vesuvius in Italy, Mount Fujiyama in Japan, Mount Kilimanjaro in Tanzania, and Mount Krakatoa in Indonesia. You can see the pictures of Mount Fujiyama and Mount Kilimanjaro. Third type of volcano is extinct volcanoes. Now extinct volcanoes are those which were active in the remote geological periods. Long back they were active and they are not likely to be active once again. So like Gorongoro in Tanzania, Arthur's Seat in Scotland, you can see they are dry and they will not erupt again, so they are called as extinct volcanoes. Now some of the facts are the supervolcanic eruptions of the world are Mount Vesuvius in Italy, Mount Krakatoa in Indonesia, Mount Pelly in West Indies, Mount Fujiyama or Fuji, a volcano worshipped by people of Japan. So they were supervolcanic eruptions of the world. They used to give lot of eruptions. Now some of them are active, some are not. Then we go to the distribution of volcanoes. Now volcano occurs in many regions of the world, including islands, young mountain ranges and plateaus of the countries. Most important regions are the circum-Pacific belt, coastal margins of the Pacific Ocean consisting of Philippines, Japan, USA, Central America, South America. You can see the map also which shows the circum-Pacific belt. You need not worry much about it. You should know. It is for your reference. You can see the volcanoes. Some of the names they ask, you can tell Japan, USA, Central America. So it is only for your reference. I have shown you the map. Then the mid-Atlantic belt, Iceland and West Indies. So here also the volcanic eruptions are there. You can see that line, red with yellow going there. Some volcanic eruptions are there. This is only for your information. Then mid-continental belt is Italy, Spain, France, Greece and Turkey. And important islands, Hawaii, Indonesia. You have to only know about them. The next one is earthquakes. Now the other internal force which changes the face of the earth is earthquake. Now we all are familiar. Earthquake is a shock or series of shock or tremors due to a sudden movement of crustal rocks generated with the crust or mantle. Now there is a sudden tremor, shock, there is a change, there are shake, and we come to know the intensity of earthquake is maximum near the epicenter and decreases with the distance from the epicenter. However, the effects of an earthquake are greater if the seismic focus lies near the surface of the earth. The point on the earth's surface vertically above the seismic focus is called epicenter. Now, the earthquakes which occur and bring a lot of disaster, now here in the earth's surface, the maximum near the epicenter where it has generated, it will be more the shake will be there and it goes on becoming less. Now the scientific study, this is important. The scientific study of earthquake is called seismology. The origin, time, velocity and direction of seismic waves are recorded by an instrument known as seismograph. So scientific study is called seismology and the instrument is called seismograph. And then you can just see here with the earthquake. It is a severe earthquake. See the condition. The buildings have fallen down. The face of the earth has changed. Then what are the causes of earthquakes? Now plate tectonics. Now the earth's crust consists of many major and minor plates. Now they will be rotating. It is like these plates are not stationary. The plate boundaries are dynamic places and are the primary location of earthquake activity. So the earth, the crust will be rotating slowly, so there will be plates. So any disturbance in that we get earthquake. Volcanic eruptions. Volcanic earthquakes are caused by gas explosions. Then faulting. A fault consists of a fracture in a rock along with a great deal of displacement takes place. Earthquakes occur when movement of plates takes place along a line of fracture. Now faulting means there is any fracture in the plates which are moving. Any change there, the earthquake takes place because the balance goes away. Now causes of earthquake in this man-made factor you should remember. Now over interaction of man with the nature is also one of the main cause of the occurrence of many of the earthquakes. The extraction of minerals, deep underground mining, huge dams and reservoirs, nuclear test, etc. what we have done, the balance, the inside the tectonic plates we have broken, so they don't get correctly to move, so the earthquake takes. The example is Koyna Dam in Maharashtra and Hoover Dam in USA. Because of this Koyna Dam, the places in and around get the earthquake because we have changed there the balance. Then earthquake waves. The earthquake or seismic waves originate in the seismic focus and travel towards the epicenter in the ripples of concentric circles. The three important earthquake waves are primary waves, secondary waves, and surface waves. Now, if you know the names, that is enough. But you should, what are primary waves? Are also known as longitudinal or compressional waves. Now, when these waves, they come, they can pass through solid, liquid, and gaseous matters. So, they reach the earth very quickly. Secondary waves are also known as transverse waves. These waves cannot pass through liquids. So, they reach the epicenter after the primary waves, because if liquid is there, they stop there only. Surface waves are also called long waves. They are slowest earthquake waves but are responsible for the highest destruction on the surface of the earth. So, only you should know them. The magnitude, this is important. The magnitude and intensity of earthquake is recorded by using Richter scale. Then the earthquakes are very dangerous and destructive. They cause large-scale death, loss to property, landslides, flash floods, damages to bridges, roads, railway lines, etc. Then a tsunami. Now, tsunami is a large sea wave occasionally experienced along the coast of Japan and in other regions caused by an underwater earthquake. In Japanese language, tsunami means harbor waves. Now, as the definition tells, it is the earthquake under the water. So, the water comes like giant. You can see in the picture. The water takes away everything. Then on 26th December 2004, a tsunami in the Indian Ocean swept the coastal, spelling is wrong, COA, coastal lowlands of Indonesia, India, Sri Lanka, Thailand, etc. In 2004, it was the first tsunami which was experienced by India. Before that, we had not seen. So, after 2004, now we have taken a precaution. On 11th March 2011, a tsunami in the Pacific Ocean caused huge damage in the eastern coastal regions of Japan. Some seismic recording centers of India are Gauribednur, this is Kodaikanal, Pune, Hyderabad and Dehradun. Here we find those seismic centers we can get. Then next we go distribution of earthquake prone regions. Now in the picture, it is only for your information. You can see the earthquake zones. The little lighter is the fracture zones and the volcanic areas. So it is only for your information. You can go through it. Then what are, now we saw the internal forces, some disturbance in the interior of the earth, the changes takes place. Now what are the external forces? Now there are many external forces. We will just look into it. The natural forces that modify the surface of the earth, important are temperature, wind, rainfall, snowfall, river, glacier. These forces act on the surface of the earth and constantly changes its features. Now first one is weathering. Now what is this weathering? Weathering is wearing away or breaking down or disintegration, that is breaking of rocks by agents like temperature, rainfall, wind present in the atmosphere. If any stone is there, constantly rain is falling, the small pieces will go and break and will start moving. So breaking down of the rocks is called as the weathering. Now there are three types of weathering. So what is weathering is important. The types only for your information. So you should know there is mechanical weathering, chemical weathering and biological weathering. So mechanical weathering, this is only for your information. When the rock is broken and disintegrated without any chemical alteration, the process is called physical weathering or mechanical weathering. Now here the agents of mechanical weathering are temperature, wind and frost. You can see how the rocks are broken. Then chemical weathering, there is a change in the composition. This is mainly brought by the action of substances dissolved in water. So this type of weathering results in changing in composition of minerals present in the rocks. Now 4 types. Oxidation. So oxygen dissolved in water reacts with certain minerals, especially iron, to form oxides. Carbonation. When the rainwater falls on limestone rocks, the calcium carbonate present in the rocks absorbs carbon dioxide from rainwater and become calcium bicarbonate. Okay. Then hydration. In this is the process by which some minerals in crystalline form absorb water and become a powdery mass. Feldspar is the common rock forming crystalline mineral. Now solution. When the rain falls on the surface of the land, rainwater dissolves solution minerals present in the rocks. Now you can see there some of the rocks formed by chemical weathering. Then biological weathering. Now this is important. Living organisms like plants, animals and human beings play a role in one way or another in weathering of rocks. Now this type includes both physical and chemical weathering. Now plants, growth and expansion of roots. Have you seen and they will break the rocks. So the breaking of the rock takes place. Then animals, burrowing animals, earthworm, rabbits, rats, etc. So then human beings, we also do by mining, quarrying, construction works, we break the rocks. Then denudation, another. First is weathering. The another external force is denudation. Denudation is the action of changing landscape or changing the surface of the earth by various natural agents like river, glaciers, underground water, sea waves, etc. Now the work of these natural agents are erosion, transportation and deposition. Now remember here these agents, rivers, glaciers, underground water, wind, what they do? They break, the upper layer is taken, transported and then deposited. In this process, some of the landforms are formed. Now these processes produce distinct relief features. Now river, a mass of fresh water flowing from its source to the mouth along a definite course is called a river. Now the river is most prominent agent of denudation. Now the place where the river takes birth is called source. Mouth is the point where river meets sea or ocean. Tributaries are the feeders or small streams which supply water to river along its course. The point where tributary joins the main river is called confluence. Now see, in this denudation, we are going to study various agents. Now all the work of these agents is, they will first erode, that is break, transport it and deposit it. In this process, some landforms are formed. Now what are these? We will see. We will go to the next, that is course of the river. Now if you have seen a river flowing, the course of the river from its source to the mouth is divided into 3 stages. Upper course, middle course and lower course. Now the upper course. In the upper course, vertical erosion is most common due to steep slopes leading to deepening of valleys, resulting in the formation of gorges, canyons, V-shaped valleys, waterfalls. Now see, when the river flows, it flows from upper end to the lower. So upper course, from up it comes, V-shaped valleys are formed. Now, and some of the waterfalls are formed. Here we have given the examples, Niagara Falls, Jog Falls in Shimoga. In the middle course, the river path has a moderate slope. It becomes little slow and velocity is less than that in the upper course. From up when it comes, it will be very fast. When in middle, it becomes little slow. The volume of water increases when many tributaries join the main river. Many tributaries come and join, and the main work of the river in this stage is transportation of sediments and little deposit. So from upper, when it is flowing very fast, it brings along with small sediments, the broken rocks. So what is its work here? Deposition. The important landforms in this stage are alluvial fans and meanders. Then we have the lower course. In this stage, the slope of the river course is very minimum. It becomes very slow. The volume of river water is more, and deposition is the main work of the river. Whatever it has brought, it deposits and falls into the ocean. So the important landform in this course are floodplains, natural levees, oxbow lakes, deltas. All these are formed. Next we will go a picture see. In upper course, V-shaped valleys are formed. Then in the middle course you see meanders. We have shown the river how it flows, the meanders, river cliffs. Then in the lower course we find the oxbow lakes, small bow-like lakes, small are formed. Floodplains and levees are formed. Then you can see here V-shaped valley, picture of V-shaped valley. Then the work of river is called as fluvial cycle. Now some of the things you should know: estuary, tidal mouth of a river broadening into the sea or ocean when it falls there. Then delta, a fan-shaped low-lying area of deposits of a river mouth. Then we go to the glacier, another agent which changes the river with the action of river. We have the V-shaped valleys are formed, then waterfalls are formed. Understood? Now what do glaciers do? Now all are familiar. Glaciers are slow moving, compacted form of ice and snow found in the high mountains and polar regions. The mass of the ice or snow is pulled down by its weight and due to the force of gravity. Now here you need not worry of all the types. Only for your information, you should know what is a glacier. So glaciers are slow moving masses of ice and are found in the high mountains and polar regions. Now what are continental glacier? As the name suggests, these are extensive ice sheets found in polar regions, example Greenland and Antarctica. Now mountain or alpine or valley glaciers found in mountain ranges. Glacier as an agent of denudation performs the work of erosion, transportation and deposition. I said all these. They will first erode, break, transport and deposit. So something is formed there. The erosional work of glacier is mainly side cutting. The landforms resulting by this are cirque, horn, arete, U-shaped valleys, hanging valleys, rock steps, etc. are formed. Now the transportation and the deposition work of glacier goes almost together. The important depositional land produced by glaciers are moraines, drumlins, esker. Now you need not worry, there are many names, but only you should remember that glacier, its work is transportation and deposition. Now here one thing you should remember, moraines. Moraines are the most important landforms of the glacier and they are of four types. That is lateral moraine, rock debris deposited along the sides of the glacier valley. Where the glaciers move on the sides, rock will be deposited. Those are called as lateral moraines. Medial means when two lateral moraines meet, it forms medial moraines. Then ground moraines means rock materials found on the floor or at the bottom of the valley. Terminal moraines are the glacial deposits found at the end of the glacier. The work of the glacier is called as the glacial cycle. Now another one, we have the underground water. What does underground water does? Underground water is the subsoil water found on account of percolation or seepage of water into the ground. Now, underground water seeps into the ground, passes through various layers of rocks. We have said that the crust is made of rocks and soil. So, the rocks which allow the water to percolate, the rocks which allow the water to pass through it is called as pervious or porous rocks, and the rocks which do not allow the water inside are called as impervious or non-porous rocks. The porous rocks beds which hold large amount of underground water are called aquifers. So the pervious rocks allows and hold water and form springs. A spring is a place where the underground water comes naturally. Now remember, this underground water is very, very important. Today we have no underground water because we have used them all. So, and what has happened? The seepage. When the rain falls, the underground water is not accumulated because everywhere we have made cemented concrete roads. So, we are finding it difficult. Now, if you are familiar, a spring is where naturally the water occurs. Now, springs are again types. Perennial spring is a spring through which water comes out continuously, as the name suggests. Intermittent springs, these are springs through which water comes out intermittently, not continuous, and they are also called periodic spring. When it rains, it comes, otherwise it may. So, hot springs, whenever warm or hot water, like a fountain, comes out naturally, it is called as hot spring or thermal spring. They are usually found near the volcanic regions. Why? Because the volcanic regions, it will be hot. So, you will get the hot water will be very hot on those springs. So earlier people used to go to these hot springs. Some minerals are involved. If you put your hand, some skin diseases go away. So those were the miracles. But scientifically it is like this. Then we go to geysers. Throw a jet of water like a fountain and steam the air at regular or irregular intervals. Example, Old Faithful in Yellowstone National Park of USA. Now these artisan wells, now it is a very interesting thing when you can see a picture also there. When underground water is stored in a basin shaped layer between two non-porous rocks. That means down one non-porous, up one non-porous rocks. Middle water will be there. So non-porous means which doesn't allow the water to pass through them. The water cannot come out naturally. When we make an artificial hole is made to the porous rock, the water comes out like a fountain. These wells are common in Australia. You can see the picture there. Okay. Next, underground water performs the work of erosion, transportation and deposition. The work of underground water is dominant in limestone region. The important landform associated with underground water are lapids, sinkholes, limestone caves, stalactites, stalagmites, pillars, etc. Now here some of the facts are limestone caves are found in Akkalgavi, Ulavi, the caves of Uttar Kannada in Karnataka, Bellam and Bohra caves of Andhra Pradesh. Here you can find this. The relief features formed by underground water in limestone region is called karstopography. Then next we go to the work of wind. Now how wind makes or forms the different thing. Now the denudation work of wind is common in the arid or desert regions. When the winds of high velocity blow over desert area, they erode, transport and deposit materials to produce different landforms. The important landforms associated with the erosional work of the wind are rock pedestals, mushroom rock, Inselberg. The depositional landforms are sand dunes, longitudinal sand dunes, breccias and losses. Now, barchans are semicircular or crescent-shaped sand deposits you can see in the picture, most common in desert. Loss is the sand particles found beyond the borders of deserts, yellow soil in China. Work of wind is called alien cycle. Next we go to the sea waves. Now the sea waves, like all other agents, sea waves are also an important exogenic agent of denudation. Now sea waves are the regular undulation of water on the sea or ocean. The work of sea waves is significant along the seashore or coast. The important landforms associated with sea waves are cliff sea, cave, sea stack, sea arch, headland, sandbar, beaches, lagoons, etc. So you can see the pictures there and what they do. Next we go to the assignment. You can see the questions. The continental crust is also called as Sial. The vast basin-shaped volcanic mouth is caldera. The most destructive earthquake waves are surface waves. Then the stalagmites and stalagmites are most common in underground water. Beaches are formed by waves. Then we have next is question answers, and then we have give reason, difference between weathering and erosion. So next we have give reasons. Now you can see the pictures and the give reasons is some rocks have a shape of mushroom. You can see the first rock. Now winds erode the lower section of the rock more than the upper part. Such rocks have narrow base and wider tops, hence they appear like mushrooms. The next is sea caves are turned into sea stacks. Now see there in the picture, sea waves are continuously strike at rocks, crack and developed over the time, and they become larger and wider. Thus, hollow-like caves are formed called as sea caves. Now see here, this is arch it has become. Before that, the behind part will be also there. As they become bigger and bigger, only the roof of the cave remain and form a sea arch. Here you can see the sea arch. Earlier it was a big rock. Further erosion breaks the roof and only walls are left. So these only one wall will be left, middle will be broken, are called as sea stacks. You have to write, give reasons, no need to draw the pictures. Pictures are for your reference. So in this lesson, it is a long lesson, but you need not worry. Only you should know which are the internal forces and external forces. So I think you have understood. You can read, and one match the following is there. I finished this lesson, and have a pleasant day. Thank you.